Hello. In this video, let's look at some of the applications of quadratic functions. So one of the applications is to look for the maximum something, revenue or maximum whatever. Now, so these are applications of quadratic functions. Now we know that quadratic function is going to make a U-shape. So a U-shape looking like this, perhaps, or a U-shape looking like this. And what are the key features that we look for in a parabola? Well, the vertex, that would be the minimum. So if we have some kind of application that gives us the, let's say, this would be the cost, and we're looking for the minimum cost. So we're looking to optimize the cost. So this is cost, and we're looking for the best cost, which is the lowest. Or maybe this is revenue, and we're looking for the highest revenue. Both are looking for the vertex of a parabola. Or we could be looking for the place where this may be a trajectory of a projectile. Maybe somebody shot an arrow or threw a stone or whatever, and it made a parabolic arc. And we can ask what is the height here and what is the height here. That's a zero height, but at what time does this happen? We can ask, so at what time is the projectile released, at what time does it come back to the ground, and what is the maximum height, and when did that happen? So these are the kinds of questions that we are asked, oftentimes run into when we deal with the applications to the quadratics. So let's look at one of them. This would be maximum revenue application. So let's suppose that we have, just for pretense, let's say that we can sell a particular item and we can sell it for $10. And at that price, we have 1,000 customers per month. So if we charge $10 a unit, we can sell 1,000 units. And we also notice from the experience that if we every $1 increase in price loses 50 customers. So let's say at $10 a unit, we have 1,000 customers, which means we would have made $10,000. So our revenue would have been 10,000 from having the price. This is our price from having the price of 10. But is it the best? Is it the highest price? Or maybe 10 is somewhere here and I'm not getting the maximum, or maybe I'm charging too much. Maybe I'm here and I need to bring the price a little bit back to get more people taking up my product and getting more revenue. So it's a delicate balance. If I increase the price by $1, I will get, each unit will be sold for 11, but I'll lose 50 people, which means I now have 950 customers. And that would be a different revenue than 10,000. So the question is, what is there? The question is, what is the maximum revenue and at what price does it occur? So let's have a setup. We have two things. So here is our revenue, and it is basically the same as this, right? It has the price times the units is going to be our revenue. So what is the price? Well, the price starts off at 10, but then we can add 1. We can increase it by $1 as many times as we want. On the other hand, we start off with 1,000 customers, and each time we increase it by $1, we lose 50 people, so we're minusing 50. That's our revenue. Now, To solve this by hand, we need to simplify it, which means we will have to multiply this equation out. And 10 times 1,000 makes 10,000. 10 times negative 50 makes negative 500x. 1 times 1,000 makes positive 1,000x. And 1x times negative 50 is negative 50x to the 2. Now, we always write the quadratics in descending order, so the highest power would be first, then the x's, then the number. But here we see that 1000x minus 500 will be 500x, and then the highest power comes first, and then the constant comes last. So this is what our revenue function looks like based on the setup. Now, we are looking for the max. We're looking for the vertex, and the vertex is given by, the vertex is negative b over 2a. So all we need is the b number and the a number. So the negative b is negative 500 divided by 2 times a, which is negative 50. So we have negative 500 divided by negative 100, which makes 5. So that means that our answer is here. The best price is x is 5, which means our best price is 10 plus 5, so the price is 15. So if we charge $15 per unit, we should get the maximum revenue. Now, at that point, we will have 5 times 50, so we will lose 250 customers, and we will have 750 customers left. But what is the revenue? That's 15 times 750, which is, using the calculator, here is 15 times 750, and that comes out to be 11,250, which means that's more than our 10,000 that we had before. So now we have 11,250. So our answer to this word problem is we should sell at $15 per unit and generate 11,250 in monthly revenue. So this would be the short answer to our word problem here. Now with the calculator, let's make a sketch and let's see if we actually get this diagram. Now we would have to do some adjustment of the window because our scale is going to be a bit off. So let's type in the equation just as it was. The original setup was one set of parentheses, 10 plus 1x, and then 1000 minus 50x. So now let's look at the picture. We're not seeing much of a picture because our U shape is way up at 10,000 units up. So one thing we can do is, I apologize here. So one thing we can do is we can change the window. So if we go to the zoom, to get an idea of what the best picture is, we can scroll past the 9. Choice 0 is zoom fit. So this is the calculator's best guess of what the window should be to make what the window should be to show all the key components. So here is the zoom, and you can see our window has changed, and we now see the parabola making the curve. And the window, as you can see, goes to our max. Now our answer was 15 for the max, so let's change it to 20. Go a little bit more. And the maximum here was, let's go even higher to, let's say, 15,000, and by 1,000, just so we can see better. So here's the same parabola. That's our revenue. And we're looking for the maximum, which is the highest revenue. So maximum, and we need to be to the left side of that maximum. Anywhere to the left is good enough. So that's far enough. And then to the right side of it, As long as I'm somewhere to the right, that's good. And then guess in the middle, yes. So here is the calculator guess, and we can see that it says 5. Again, that's a rounding error. It should be 5. And then our max is 11 to 50, which is exactly what our maximum revenue turned out to be. And that's it for this video. And in the other video, we can look at optimizing something else. So these are the type of classical problems, the minimizing, maximizing the areas, the projectile motion, and so on. So that's it for this video. Thanks a lot. Take care.